Welcome to a journey that will challenge everything we thought we knew about human history. The year 2025 has been nothing short of extraordinary for archaeology and ancient studies. As we stand at the intersection of cutting-edge technology and age-old mysteries, discoveries made this year have fundamentally altered our understanding of what ancient civilizations were truly capable of achieving. For decades, we've operated under certain assumptions about our ancestors, that they were primitive, limited by their tools, constrained by their knowledge. But what if those assumptions were wrong? What if the ancients possessed technologies and understanding that rivaled, or perhaps even surpassed, our own in certain ways? This year, archaeological teams working across 4 continents have unearthed evidence of technological sophistication that has left the scientific community both bewildered and excited. These aren't just interesting artifacts or curious anomalies. These are game-changing discoveries that force us to reconsider the entire timeline of human technological development. Today, we'll explore 5 groundbreaking discoveries from 2025 that have rewritten the textbooks. We'll journey from the depths of the Amazon rainforest to the windswept plateaus of Central Asia, from submerged cities beneath the Mediterranean to hidden chambers deep within Egyptian monuments. Each discovery tells a story of ingenuity, of problem-solving, of human brilliance that transcended the supposed limitations of ancient times. But before we dive into these remarkable findings, it's worth considering why these discoveries matter. They're not merely academic exercises or points of historical curiosity. Understanding how ancient peoples solved complex problems can inform our own approaches to modern challenges. Their sustainable technologies, their astronomical knowledge, their engineering marvels, all of these hold lessons for a world grappling with climate change, resource scarcity. Deep in the Brazilian Amazon, in a region that had remained largely unexplored due to its remoteness and dense vegetation, archaeologists made a discovery that seemed almost impossible. Using LiDAR technology, a laser-based remote sensing method that can penetrate forest canopy, researchers identified a massive complex of earthworks covering over 200 square kilometers. When excavation teams finally reached the site in March 2025, what they found defied all expectations. This wasn't just another settlement or ceremonial center. It was a sophisticated computational system, built entirely from earth, water, and stone, capable of performing complex calculations and storing information. The system, which researchers have dubbed the Terra Calculator, dates back to approximately 1200 CE, predating European contact by nearly 3 centuries. It consists of a vast network of raised platforms, water channels, and carefully positioned stone markers. But here's where it gets truly extraordinary: this entire system functioned as an analog computer. Dr. Maria Santos, the lead archaeologist on the project, explained that the ancient engineers had created a hydraulic computing system. Water flow through the channels, controlled by a series of gates and locks, could be manipulated to represent numerical values. Different water levels in various basins corresponded to different calculations. It's similar in principle to how ancient Greek water clocks worked, but vastly more sophisticated. The Terra Calculator could perform addition, subtraction, multiplication, and even basic division. But even more remarkably, it appears to have been used for astronomical calculations. Stone markers positioned throughout the complex align with solar and lunar events, and the water system could be adjusted to track celestial cycles over decades. Evidence suggests this system was used to predict agricultural cycles, plan planting and harvesting, and even forecast weather patterns based on astronomical observations. The precision is astounding. Researchers have verified that calculations performed using reconstructed sections of the system match modern astronomical data to within a fraction of a percentage point. But perhaps the most mind-blowing aspect of the Terra Calculator is its information storage capability. The system included what can only be described as a physical memory storage system, a series of movable stone markers that could be positioned in specific patterns to record data. It's essentially a 3-dimensional database, built from earth and stone, that could store information about crop yields, population counts, resource distribution, and astronomical observations spanning generations. This discovery has forced archaeologists to completely reconsider the technological capabilities of pre-Columbian Amazonian cultures. For too long, these societies were dismissed as primitive compared to the great civilizations of Eurasia. The Terra calculator proves that sophisticated computational thinking existed in the Americas long before European arrival, developed independently and suited perfectly to the needs and environment of Amazonian peoples. The implications extend beyond archaeology. Engineers and computer scientists studying the Terra calculator have noted that its analog approach to computation offers insights into alternative ways of processing information. In an age where digital computing faces certain limitations, particularly in terms of energy consumption, the efficiency of this hydraulic system is remarkable. It operated using only gravity and manual water control, yet performed calculations that would have been impossible for any individual to complete mentally. Our second discovery takes us beneath the waves of the Mediterranean Sea, where marine archaeologists made an unexpected finding that has revealed an ancient communication network of breathtaking sophistication. Off the coast of what is now southern Turkey, diving teams investigating a known ancient harbor made an unusual observation. Stone pillars, dating back to approximately 300 BCE, were positioned at seemingly random intervals across the seafloor. Initially dismissed as the remains of collapsed structures, closer examination revealed these pillars were intentionally placed in their current positions, and they formed a pattern. Dr. Andreas Papadopoulos, leading the research team, realized that these stone structures weren't architectural at all. They were acoustic devices, a network of underwater sound transmission stations that could carry messages across vast distances. The ancient engineers had discovered and exploited a fascinating property of underwater acoustics. Sound travels approximately 4 times faster through water than through air, and under the right conditions, it can travel for enormous distances with minimal loss of clarity. The Mediterranean, with its relatively stable conditions and specific depth profiles in certain areas, was ideal for this application. Each stone pillar was carefully carved with specific shapes and hollows that acted as acoustic resonators. When struck or vibrated in particular ways, they would produce distinct sound patterns that could be picked up by the next station in the network. The spacing between stations, typically between 5 and 8 kilometers, was precisely calculated to maximize transmission while accounting for ambient noise and environmental conditions. Testing conducted this year confirmed that the system actually works. Researchers recreated the conditions using replica pillars and modern underwater monitoring equipment. Messages transmitted through the network could be detected clearly at distances exceeding 50 kilometers, traveling through multiple relay stations. But this wasn't just a simple communication system. Analysis of the carvings and acoustic properties reveals a sophisticated encoding system. Different sound patterns corresponded to different messages: warnings of approaching ships, notifications of weather conditions, coordination of fishing fleets, and even commercial information about cargo and trade routes. The network appears to have covered most of the eastern Mediterranean, with over 300 identified stations discovered so far. This suggests a level of maritime coordination and communication that historians hadn't imagined possible for the ancient world. Cities separated by hundreds of kilometers could effectively communicate within hours, not days or weeks. What makes this discovery particularly significant is how it demonstrates ancient understanding of physics and engineering. The people who built this system understood sound propagation, resonance, and signal encoding. They had mapped the seafloor, tested acoustic properties, and engineered a solution to a complex communication problem using nothing but stone and an understanding of natural phenomena. Modern naval engineers studying the system have noted its elegance and efficiency. Unlike many modern communication systems that require power sources and sophisticated electronics, this network operated using only human effort and natural acoustic properties. It was sustainable, durable. Many of the pillars have survived over 2,000 years underwater, and required no maintenance beyond keeping the resonating chambers clear of debris. The discovery has sparked new searches for similar systems in other ancient maritime regions. Preliminary surveys suggest that acoustic communication networks may have existed in other parts of the ancient world, from the Aegean to the Red Sea, anywhere that ancient peoples had both maritime commerce and the engineering knowledge to exploit underwater acoustics. High in the mountains of Kazakhstan, our third discovery might be the most technologically advanced of all. In May 2025, a geological survey team noticed unusual mineral deposits around a series of ancient stone towers. What they'd stumbled upon was evidence of an energy harvesting and distribution system dating back to approximately 800 CE. The site, located at an elevation of over 3,000 meters, consists of 27 towers arranged in a precise geometric pattern across a plateau spanning 15 square kilometers. Each tower stands between 10 and 15 meters tall, constructed from carefully fitted stones. But it's not the construction that's remarkable, it's what these towers were designed to do. Analysis of the mineral deposits revealed high concentrations of metallic ores and crystalline structures that could only have formed through repeated exposure to electrical discharge. The towers, researchers realized, were lightning rods, but not for protection. They were designed to harvest atmospheric electricity. Dr. Yevgeny Volkov, a physicist working with the archaeological team, explained that the ancient engineers had created a system to capture, store, and distribute electrical energy from lightning strikes and atmospheric charge. The towers were positioned to maximize lightning attraction during the region's frequent storms. Metallic elements within the stone construction conducted the electrical charge down into underground chambers. These chambers contained what can only be described as primitive batteries, large clay vessels lined with specific combinations of metals and filled with acidic solutions derived from local minerals. When electrical charge from lightning strikes or atmospheric buildup flowed into these vessels, it would be stored as chemical energy through electrochemical reactions similar to those in modern batteries. The stored energy was then distributed through a network of copper cables, yes, copper cables in the 9th century CE, to various locations throughout the settlement. Evidence suggests this electricity was used for several purposes: heating buildings during harsh mountain winters, providing light, and possibly even metalworking operations that required high temperatures. The sophistication of this system is staggering. The ancient engineers understood not just that lightning was electrical, they understood how to harness it, store it, and use it. They had developed knowledge of conductors and insulators, of electrochemical storage, of circuit completion. This wasn't accidental discovery or primitive fumbling. This was deliberate, informed engineering. What makes this even more remarkable is that this technology appears to have been lost. There's no evidence of it spreading beyond this region, and it seems to have been abandoned within a few centuries, possibly due to political upheaval or environmental changes. The knowledge that created it vanished, not to be rediscovered until humanity developed similar technologies in the 18th and 19th centuries. Modern engineers examining the system have noted several clever design features. The towers were positioned not just for lightning attraction but also to create a slight potential difference during normal weather conditions, essentially trickling charge from atmospheric electricity even when storms weren't present. The battery vessels were designed with specific dimensions and material combinations that maximized storage capacity while minimizing degradation. Some of the vessels still show evidence of their metallic linings over 1,000 years later. This discovery raises profound questions about technological development and knowledge transmission. How did this community develop such advanced understanding? Was it built upon earlier knowledge that we haven't yet discovered? And why didn't this technology spread or persist? From electrical engineering we turn to optical engineering, with our fourth discovery made within the Giza complex itself. In August 2025, during conservation work on lesser-known structures surrounding the famous pyramids, workers discovered a hidden chamber containing dozens of bronze mirrors and optical devices of remarkable precision. Dr. Fatima Hassan, director of the project, initially thought these were ceremonial objects. But careful examination revealed something far more interesting. These mirrors, some as large as a meter in diameter, were ground and polished to optical precision. When researchers analyzed their curvature and positioning, they realized these weren't for vanity or ceremony, they were components of a communication system. The ancient Egyptians had created a line-of-sight optical telegraph, capable of transmitting messages across the Nile Valley at the speed of light. Bronze mirrors positioned on towers and elevated structures could reflect sunlight in coded patterns, visible for dozens of kilometers to the next station. At night, oil lamps with focusing mirrors served the same purpose. But this wasn't simple on-off signaling. The system was far more sophisticated. The mirrors could be precisely angled to create different reflected patterns. Multiple mirrors working together could transmit complex messages using a coding system that researchers are still working to fully decipher. Evidence from hieroglyphic texts found in the chamber suggests operators of this system underwent years of training to master both the encoding system and the precise mirror manipulation required. The range and coverage of this network were extensive. Archaeological surveys conducted throughout 2025 have identified over 60 stations stretching from the Nile Delta to Upper Egypt, a distance of over 800 kilometers. Messages could be relayed from Alexandria to Aswan in under an hour, a feat that wouldn't be matched until the advent of electrical telegraphs in the 19th century. What's particularly fascinating is how this system was integrated into Egyptian administration and military operations. Hieroglyphic records describe its use for everything from alerting garrisons about approaching threats to coordinating Nile flood responses to transmitting royal decrees. The system gave Egyptian rulers something unprecedented in the ancient world: real-time communication and coordination across their entire kingdom. The optical precision of the mirrors is astounding. Modern analysis shows they were ground to tolerances that wouldn't be achieved again until Renaissance lens-making. The bronze alloy used was specifically formulated for maximum reflectivity and durability. Some mirrors, protected from the elements in sealed chambers, retain a reflective quality even after 3,000 years. Researchers have reconstructed a working section of the system, and the results are impressive. Using replica mirrors and the ancient positioning data, they successfully transmitted encoded messages across distances exceeding 30 kilometers with perfect clarity. The system's bandwidth, its capacity to transmit information, is surprisingly high. An experienced operator could transmit approximately 100 distinct signals per minute, comparable to early electrical telegraph systems. This discovery has implications for our understanding of ancient Egyptian statecraft. The ability to communicate rapidly across vast distances would have given Egyptian rulers unprecedented control and coordination. It explains how Egypt maintained cohesion across such a large territory and responded so effectively to external threats and internal challenges. Modern military historians studying the system have noted its strategic brilliance. It provided secure communication. Intercepting a light beam message was virtually impossible without being detected. It was fast, limited only by line of sight and operator speed. And it was environmentally powered, requiring no resources beyond sunlight or lamp oil. Our final discovery takes us to the Andes Mountains of Peru, where an international team made perhaps the most practical and immediately relevant discovery of 2025, an ancient earthquake detection and early warning system of remarkable sophistication. In the mountains above Cusco, archaeologists investigating Inca-era structures noticed something unusual. Small stone buildings, previously thought to be shrines or watchtowers, contained peculiar features: suspended stone weights, carefully balanced on pivots, surrounded by shallow channels filled with water. When an earthquake struck the region in July 2025, researchers watching these structures were amazed to see the ancient systems activate, with weights swinging and water sloshing in predictable patterns. This triggered intensive study of what turned out to be an extensive network of seismic monitoring stations, dating to approximately 1400 CE, covering much of the Inca Empire. The system was designed to detect earthquakes, measure their intensity, and provide warning to population centers. The genius of the design lies in its simplicity and reliability. The suspended stone weights, essentially sophisticated pendulums, were calibrated to respond to ground motion. Different weight sizes and suspension lengths made them sensitive to different types of seismic waves. The water channels amplified and made visible the motion, allowing operators to quickly assess earthquake characteristics. But the Incas went further. They understood that earthquake waves travel through the earth at finite speeds, and that different types of waves, compression waves, shear waves, surface waves, travel at different rates. Stations positioned at various distances from geologically active zones could provide minutes of warning before the most destructive waves arrived at population centers. The network included a rapid communication system, runners stationed at regular intervals who could carry earthquake warnings faster than the destructive waves traveled. For earthquakes originating in the mountains, coastal cities could receive 10 to 15 minutes of warning, enough time to evacuate vulnerable structures and prepare for the shock. Dr. Carlos Mendoza, a seismologist studying the system, noted that this represents genuine understanding of seismology, the science of earthquakes. The Incas had observed, experimented, and developed functional models of how earthquakes work and how to measure them. They'd created instruments that, while simple compared to modern seismographs, captured the essential information needed for public safety. Testing of reconstructed monitoring stations shows they're remarkably sensitive and reliable. They can detect tremors too subtle for humans to feel, distinguish between different types of ground motion, and provide useful data about earthquake characteristics. Modern seismologists have noted that the basic principles used by the Inca system, using multiple sensors with different sensitivities, comparing data from different locations, and understanding wave propagation, are the same principles underlying modern earthquake early warning systems. What makes this discovery particularly relevant today is its applicability. Many regions of the world, especially in the developing world, lack sophisticated earthquake monitoring and warning systems. The Inca approach, low-tech, reliable, requiring no power source, and buildable using local materials, could be adapted for use in vulnerable regions where modern systems are economically unfeasible. Pilot projects are already underway in several countries to build modern versions of these ancient monitors. They're being called appropriate technology solutions that match the needs, skills, and resources of the communities using them. As we reflect on these 5 extraordinary discoveries from 2025, several themes emerge that challenge our understanding of history and technology. First, we must abandon the notion of linear technological progress. History isn't a simple story of primitive beginnings leading inexorably to our advanced present. These discoveries show that ancient peoples achieved technological sophistication in specific domains that was later lost and only recently rediscovered or surpassed. Progress isn't a straight line, it's a complex web of innovation, loss, rediscovery, and reinvention. Second, these discoveries reveal that ancient peoples were far more capable of abstract thinking and scientific reasoning than we've credited. They observed natural phenomena, formed hypotheses, conducted experiments, and developed functional technologies based on sound scientific principles. The computational thinking behind the Amazon Terra calculator, the acoustic engineering of the Mediterranean network, the electrical science of the Central Asian energy grid, the optical precision of the Egyptian communication system, and the seismological understanding of the Andean monitoring network, all of these required sophisticated reasoning and systematic experimentation. Third, we see that ancient peoples developed technologies specifically suited to their environments and needs. They weren't trying to recreate technologies from elsewhere, they were solving local problems using local resources and local knowledge. This is sustainable innovation at its finest, technology that works with rather than against natural systems. The practical implications of these discoveries extend far beyond academic interest. Engineers worldwide are studying these ancient systems for inspiration and practical solutions. The hydraulic computing approach of the Terra calculator offers insights into low-energy computation. The acoustic network principles are informing development of underwater communication systems. The atmospheric electricity harvesting techniques are being explored for remote power generation. The optical telegraph system demonstrates the potential of free space optical communication. And the seismic monitoring network is being adapted for use in vulnerable regions. Perhaps most importantly, these discoveries remind us of the value of diverse approaches to problems. Modern technology tends toward increasingly complex, energy-intensive solutions. The year 2025 will be remembered as a turning point in archaeology and ancient history. These 5 discoveries have fundamentally altered our understanding of what ancient civilizations were capable of achieving. They've shown us that our ancestors were far more ingenious, knowledgeable, and sophisticated than we imagined. They've demonstrated that important innovations occurred independently across the globe, that human ingenuity transcended the limitations of time and place. But beyond the academic implications, these discoveries offer something more profound: hope and inspiration. In a world facing complex challenges from climate change to resource scarcity to social inequity, we can look to the past and see examples of human creativity overcoming seemingly impossible obstacles. Ancient peoples with limited resources and primitive tools created technologies that achieved remarkable things. They observed, questioned, experimented, failed, tried again, and ultimately succeeded. We stand on the shoulders of countless generations of innovators, stretching back thousands of years. The technologies discovered in 2025 aren't just archaeological curiosities, they're testaments to human potential, reminders that creativity and determination can overcome any challenge, and guideposts pointing toward sustainable, elegant solutions to modern problems. As we continue to uncover the technological achievements of our ancestors, we're not just learning about the past. We're discovering tools and approaches that can help build a better future. The ancient technologies discovered in 2025 bridge millennia, connecting the ingenuity of the past with the possibilities of tomorrow. And perhaps that's the most important lesson of all, that human innovation is timeless, that solutions can come from unexpected places, and that we have much to